158 is in the middle of this bar. So to include this bar of 158, we have to scoot over the value just a little bit. So we're going to have to say x has to be greater than 157 and a half. This is very much like when we were doing class boundaries and we were doing, pushing them together to make that 0.5. So to include this whole bar, we need to scoot it over and make it 157 and a half. Here would be 157, by the way. Right there. Okay, probability of getting less than 63 successes. Zandy is doing fine. His chin was pretty gaping open when I saw him at first, which freaked me out, but super glue is an amazing thing, so he's all good now. Now he just has to not pick at it. Okay, so this time we're going for less than 63 successes. So what you should be thinking to yourself right now is, do I need to include this bar or should I not include this bar? But we want less than 63, so we really want here and over. We don't want to include the bar. So that means x has to be less than 62 and a half. So you can't always think, ooh, I'm always going to go to the left or I'm always going to go to the right. You have to think about whether that bar is included or not. And if it's less than 63 successes, then we need to go to the left. If it was greater than 63 successes, we'd go to the right. But if it's at least or at most, then you really have to think about whether that bar is included or not. Okay. So I'm going to start doing this with you guys where we've got specific instructions on how to do these problems. On one side, I'm going to call this a T-chart. On one side, we've got directions, and on one side, we've got things that we're remembering. Look, I got a coffee from the hospital. Isn't that exciting? Not my favorite place to get coffee, but it is what it is. Okay. So the first thing you have to do is you have to verify that it is binomial. And remember, if you tried putting this binomial problem into your calculator and the n ends up being really high, your calculator can't even do that because your calculator is technically, like when it does a cumulative probability, it is doing all of those formulas and then adding them all up together. And once it gets over like 100 formulas, the calculator can't handle that much math anymore, so it can't do it. All right, so things to remember is to specify n, p, and x. And q, but q kind of goes with p. All right, next you need to determine whether you can use a normal distribution. So can you use a normal distribution? The thing that tells you that is you check and see if n times p is greater than or equal to 5, and if n times q is greater than or equal to 5. And if that's true, then you're good to go. And remember, if it's less than that, you just use a binomial distribution, but you see how if here n times p is 1, n times p is 3, n times p is 2.5, that's too low. See, it doesn't really look normal yet. But once it starts getting high enough of an n, and as long as your p is high enough, or your q is high enough, then it does start making a normal distribution. Otherwise, it's like super crowded over here on one end. So like imagine if your p was too low, then it would be over here, that big bell curve, and it would only be like half of it. Or if your q was too high, then it would be over here and only be part of it. So that's the thing you have to check. Okay, next thing you do is you find the mean and standard deviation. And we know that the formulas for that from last chapter, the mean is n times p, and the standard deviation is the square root of npq. So that's not something that's going to be too challenging to do. Number 4, you apply A continuity correction. The thing to remember there is, do you include that bar in the bar graph, just like we were just trying, and you're either going to add 0.5 or you're going to minus 0.5, depending on that. And that always happens. So in these problems, you will always be adding or subtracting that 0.5. Next, you're going to draw a picture. Actually, even drawing a picture might have been better on that step. And then you find a z-score. So that's our standard x minus mu over sigma to get your z-score. But remember, x is the thing that will change with that continuity correction. And if you're confused right now, don't worry, we're about to do a whole bunch of examples, so you'll figure it out. And then finally, find the probability that is associated with that z-score. And that is the table that I gave you, A16, which is the page number, I guess, at the bottom of the table. Okay. Next one, here we go. Excuse me. Okay. So, what percent of people do you think have admit that they snoop in other people's medicine cabinets? I think that's an excellent question. So it turns out that the amount of people that admit that they snoop in other people's medicine cabinets when they go to other people's houses is actually 40%, which seems crazy, but apparently true. Maybe 40% of you, that would be 4 out of 10 of you, would snoop in somebody's medicine cabinet when you go to their house. See what kind of meds they're on, see what they got, open up their mirror. So what's the probability that at least 70 will say yes out of 200 people? Okay, so the first thing I'm going to do is verify that this is binomial. Here I've got n is 100. I've got that p is 40%, so 0.4, which means q is 0.6. I think I'm going to change it up here and change it to specifying n, p, and q, because in this case x is 70, but that's not really important. The important thing that you need is n, p, and q. Okay, so now what I'm going to do is make sure that I can do this. No, n was 200, not 100. So if I take 200 times 0.4, which is the smaller one, that is 80, which is definitely bigger than 5. I'm not going to even check 0.6 because I know that that will be larger. But also, sometimes you don't even need to write it down. You would write it down on an AP exam to prove that you are testing it, but I'm hoping that you would know that 40% of 200 is bigger than 5. That's a hope, at least. So, but if you need to check it, then you can check it. So the next thing we do is we put out mu. Mu is n times p. We just figured out n times p, so mu is 80. And then the standard deviation is the square root of n times p times q. So in my calculator on my phone, I'm going to type in, let's see, I want 200 times 0.4 times 0.6. I got 6.9, about 6.93. Okay. All right, now I'm going to draw a picture and figure out my continuity correction. So I'm just going to draw a teeny little bar graph here. Beautiful. And let's say that, I don't know, 80 is this one. Okay, or no, 70, because 70 is what I care about. 70 is right there. It says at least 70 will say yes. That means that that would be 70 or more. So that includes 70. So I'm going to have to back it up to 69.5. So I need x is greater than 69.5. So now in my math, I'm going to do 69.5 x minus mu over sigma, x minus mu over